Hello, my name is Natalia and I am an electrical engineering student at Idaho State University. Today I will be introducing and demonstrating the use of the Advanced Active Learning Module, or the ADALM2000. It is also called the M2K for short. The M2K is a device that is capable of providing the functionalities of several different types of analog and digital electronic lab equipment. In this video, we will briefly discuss the 9 devices that can be represented by the M2K. These include a power supply, voltmeter, signal generator, oscilloscope, network analyzer, spectrum analyzer, logic analyzer, pattern generator, and digital I/O. This pinout diagram represents the pins located at the bottom of the ADALM2000 or M2K device. This pinout is also located on the bottom front of the device for easy reference. The M2K also comes with a USB power cable to plug it into your computer, as well as 2 different wire set combinations that plug into these pins, one for digital devices and the other for analog devices. A more detailed implementation of the analog probes will be shown in the next video. Before we get into the devices, I will first introduce the concept of the breadboard. The solderless breadboard, commonly used in educational environments, consists of metal strips covered by hard plastic. Because there is no soldering or melting, and thus permanently combining the components, the breadboard is reusable. This makes it a good choice for creating and experimenting with circuit design in educational settings. The plastic cover of the breadboard contains many small holes that allow electrical components to be plugged into the breadboard in order to create a circuit. When the breadboard is oriented so that the letters are in the upright position, the positive and negative power rails are connected vertically, while the numbered rows are connected horizontally. When connected to either side, this means that the power supply can power both the entire column, and any component plugged into the breadboard will be connected to another component if they share the same row. Now that I've introduced the breadboard, we can now discuss the 9 devices of the M2K. For each of the following explanations, I will also show photos of the physical instruments contained by the M2K, but understand that these devices are all within the M2K, so all you'll need to complete work that requires these tools is this singular device. A power supply is a piece of electrical equipment that delivers a range of AC or DC voltage to a circuit. The output voltage control of the M2K is adjustable from 5 volts to 0 volts on the positive output and 0 volts to negative 5 volts on the negative output. When connected to a circuit by use of a power lead, negative lead, and ground lead, the power supply can supply power to the circuit. An actual power supply may have dials to adjust the voltage and current, but the M2K has the following layout. After the circuit is connected, the value of the voltage can be set on the right-hand side of the screen, and the Enable button can be used to supply power or remove power from the circuit. To use the power supply on the M2K, the ground pins and the V+ and V- pins are utilized. This will be further explained in the next video. A voltmeter is a device used to measure the voltage across an electrical circuit or electrical component. In terms of actual devices, a digital multimeter is a piece of equipment that can be used to measure current and resistance in AC and DC circuits in addition to voltage. For the voltmeter, there is no need to adjust the unit of measurement as it only measures voltage. However, for the digital multimeter, it becomes important to pay attention to the unit of measurement you wish to take. In order to measure these values, positive and negative test leads are used to coincide with the circuit or component you wish to examine. On a digital multimeter, the measurement will display once the connection is made. On the M2K, the measurement will display when the Run button at the top right corner is pressed. The voltmeter also keeps track of the change in voltage over time while using the device. There are two possible channels that can be used to measure voltage, and these are represented by the 1 plus and 1 minus and 2 plus and 2 minus wires from the analog probes. A signal generator produces an electrical signal which can then be used to analyze a circuit. It may also be called a function generator, tone generator, or waveform generator. It can produce constant signals or sine, square, triangle, trapezoidal, rising and falling ramp sawtooth, or stair-step waveforms. Again, it is connected to a point of interest in the circuit via positive and ground leads, which will be shown in detail in the next video. The signal itself is formed based on parameters set by the user. For the M2K, these parameters include amplitude, offset, frequency, and phase. On an actual signal generator, these values are changed using a combination of buttons and dials. However, on the M2K, you can simply type or click to change them in the right-hand side of the screen, and then press Run at the top right corner to produce the signal. The M2K can produce two waveforms by use of the yellow W1 and W2 analog output pins. An oscilloscope is a piece of electronic test equipment that displays voltage over a time period at different points in a circuit. The oscilloscope displays this information in the form of a grid with time in terms of unit per division, and on the horizontal axis, and voltage in terms of volts per division on the vertical axis. It typically has more than one input channel, which is true for the M2K as well. The front panel of an actual oscilloscope contains a display screen and controls to manipulate the display in terms of the time base and Y amplifier. On the M2K, these buttons are again replaced by controls on the right-hand side of the screen. Similar to the previous devices, positive and ground leads are used to connect the oscilloscope to a point in the circuit in order to take waveform measurements at that point. This will be shown in detail in the next video, but for now we can see that the period, frequency, peak-to-peak amplitude, and mean voltage are all displayed for each channel. On the pinout of the M2K, the two channel probes 1 plus, 1 minus, and 2 plus, 2 minus are again used to take oscilloscope measurements. A network analyzer tool is used to measure the network parameters of electrical networks or electrical circuits. In the case of devices with two-port networks, the terminals consist of an input and output voltage and an input and output current. The values of these voltages and currents determine the values of the network parameters to be analyzed. The network analyzer computes the frequency response and phase response of the circuit and shows this information on one or two graphs that can be observed on its display screen. On the M2K, both the amplitude and phase angle graphs can be viewed simultaneously. The top graph exhibits the amplitude or gain in decibels over a range of frequencies, while the bottom graph exhibits the phase angle in degrees corresponding to the amplitudes in the same frequency range. It is also important to note the significance of the single button. Although the run function can also be used, the single button allows for a single sweep to be recorded rather than a continuous run of the network analyzer. This single function is also available on the oscilloscope, logic analyzer, spectrum analyzer, and pattern generator of the M2K. Before or after a single sweep has been performed, you can select the three stacked lines symbol at the top right-hand corner to make adjustments to the graphical display. It is possible to change the scale, dimensions, and other characteristics using controls on the right-hand side of the screen. On the pinout of the M2K, the two analog probes, +1 and -1, and +2 and -2, are used again along with either the W1 or W2 analog output pin to connect to the network analyzer with a circuit and create a signal. When a device or circuit gives off a certain signal, A spectrum analyzer tool is used to measure the magnitude of an input signal against a full range of frequencies. This measurement can be used to determine the power of both known and unknown signals. On the M2K, we can use the spectrum analyzer to observe the signals from a connected circuit or device. You can see the 3 stacked line symbol at the top right-hand corner to make adjustments to the graphical display. Again, it is possible to change the scale, dimensions, and other characteristics of both frequency and amplitude using controls on the right-hand side of the screen. On the pinout of the M2K, the 2 analog probes, 1+, 1- and 2+, 2- are used again, along with either W1 or W2 analog output pins to connect the spectrum analyzer to a circuit and measure the signal. A logic analyzer is an instrument that analyzes digital circuits by capturing and displaying multiple signals from the digital circuit. These signals are categorized according to high state and low state voltage behaviors. A digital circuit is one that uses logic gates to determine high or low voltage states. We will discuss the concept of logic gates more thoroughly in class, but for now, understand that this table shows the different characterizations of high state and low state that are commonly used in this course. They can also be referred to as high voltage and low voltage, typically in a range of about 5 volts for high and 0 volts for low. These voltages are also represented by logic numbers 1 and 0, or said to be either on or off. On the M2K, the right-hand side of the screen shows some controls to set the sample rate and number of samples for the logic analyzer, and there is also a section to view the available channels. On the pinout of the M2K, the 16 digital input or output pins are used to implement the logic analyzer. A pattern generator is a piece of equipment used to generate digital electronic stimuli, which are electrical waveforms varying between high state and low state voltages, represented respectively by 1s and 0s. The pattern generator is used in place of inputs of a digital electronic device. On the M2K, we can see the plot area of the pattern generator with the horizontal timescale, as well as the available channels to the right. To enable or disable these channels, simply click to turn them on or off. On the pinout of the M2K, the 16 digital input or output pins are used to implement the pattern generator. Digital I/O stands for digital input and output. It uses a microcontroller to detect and output logic states of a device or circuit. Digital input detects whether a voltage is above or below a certain threshold, and digital output allows the users to control their voltage output, falling either under high or low specifications. As mentioned earlier, these logic states are characteristics of digital circuits, and this table shows how the states are categorized. On the M2K, you can see that there are 16 digital channels, each with their own toggle button to designate them as input or output, or to logic 1 or 0. These channels can also be set to operate individually or as a group of 8. On the pinout of the M2K, the 16 input or output pins are used to implement the digital I/O tool. Finally, here are the references I used to make this video. I hope you have found this video helpful and that it has increased your understanding of the 9 devices contained in the M2K. If you have any questions about anything I've shown in this video or questions about your course in general, please feel free to contact your professor or lab TA via email. Their contact information is available on the class syllabus on Moodle.